today we are learning the unit circle. I need you to go ahead and copy down these two definitions at the top. So you need to copy down the definition for a unit circle. So you have some room in the top margin, you might have to write small, or turn it and do it in the side margin. So the definition for a unit circle is a chart or circle of special trig value with a radius of 1. And I'll give you time to copy that down. Is a chart or circle of special trig value with a radius of 1. So we'll be splitting up a circle, and we'll be splitting it up into different degrees, and we'll be talking about what are the degree measures and what are the radian measures. And we'll talk about radians here in a few minutes. Next definition for today is called standard position. And it says an angle is in standard position if its vertex is located at the origin. So here would be the vertex. And one ray is on the positive x-axis. And this ray on the positive x-axis is called the initial side. What does initial mean? Beginning. So that's the initial side of the angle. And the other ray is called the terminal side. Now for standard positions, really the best way to define it is by picture. So everything I drew on red, there's my picture definition. So its vertex is at the origin at 0, 0. And the initial side is on the positive x-axis. So this is the starting ray. And the terminal side is going to be the second side. Now over here, it talks about positive rotation. And when we talk about angles on the unit circle, we typically use positive rotation, which means we start at the positive x-axis and we're going counterclockwise. So positive rotation means you go counterclockwise. So positive rotation means we're going counterclockwise from the positive x-axis. Now if we went clockwise from the positive x-axis, that would be negative rotation. So for our purposes, you need to know that we start at the positive x-axis and we go counterclockwise. So the opposite way of a clock. Now for these first three circles, it says to label each angle using degree measure and positive rotation. So let me get rid of my picture definition. I'm going to keep the initial side on the positive x-axis. So when we're measuring our angles today, it would be with respect to the positive x-axis. Now, what is my terminal side? Look right here. Well, first of all, what is this degree right here? started at 0 degrees. So 0 degrees is at the end of the positive x-axis. And at the top, we have 90 degrees. Now, if you notice, that was a 90-degree angle. It does make a right angle, so that is 90 degrees. Another way we could have found that is looking at that angle. Let me highlight it. Looking at this section of the circle. We know how many total degrees are in a circle. How many total degrees in a circle? 360, and this section makes up what fraction of that circle? 1/4. So what's 1/4 of 360? 90 degrees. So each of these are 90 degrees. So continuing on, again, my initial side is staying on the positive x-axis. So now with the terminal side, we're over here. 180 degrees. And for the next one, the initial side is staying on the positive x-axis. So what if the terminal side is over here? How many degrees would that be? 270 degrees. And if I made one complete revolution, if my initial side and terminal side were in the same location, so what if I made one complete revolution and my ending or terminal side is the same place where I started? How many degrees would that be for one revolution? 360. So that could be 0 degrees, and it's also 360 degrees. So you need to have both of those answers, 0 and 360. And don't forget those degree symbols. Now I'm going to change colors so that things don't get confused. Now looking at problem number 2. Same thing, we need to split up that circle into degree measures. So over here, this starting side, what do we start at over here? 0 degrees. And over here would be how many degrees? From here to here. 180 degrees. So this one is 180 degrees. So that's 180 degrees. What would this one be? 90 degrees. And this one, I'm getting too many lines here. This one is halfway, so what's half of 90? 45 degrees. So this circle, each one of these is a 45-degree angle. So 45 plus 45 gets us to 90. What's 90 plus 45? 135 degrees. 135 plus 45 gets us to 180. 180 plus 45 gets us to 225. And what's 225 plus 45? 270. What's 270 plus 45? 316 degrees. Next circle.
Wait, you don't have the 316 on that one?
Oh, yes. I need to go one more. What's 315 plus 45? 360, so make sure you have both answers. Now that's just for one revolution. I could keep going. I could do 360 plus another 45 and be at 405. Do another 45, be at 450, etc., etc. Okay, now number 3. Over here on the right side, what angle do we start at? This one's 0 degrees, and over here is 180. And up here at the top would be 90 degrees. And looking at this angle right here, what fraction of 90 is it? 1/3 of 90. So 1/3 of 90 degrees would be how many degrees? 30 degrees. So each of these is counted by 30 degrees. So 30 plus 30 gets us to 60. 60 plus 30 gets us to 90 plus 30 gets us to 120. 120 plus 30 gets us to 150. 150 plus 30 gets us to? 180. And 180 plus 30 gets us to? 210. 210 plus 30 gets us to? 240. 240 plus 30 gets us to? 270. 270 plus 30 gets us to? 300. 300 plus 30 is? 330 degrees. And 330 plus 30 would be 360 degrees. Now, before you move on, right beside this one, you have some empty space over here. So in this empty space, I want you to use your compass to draw a circle. So in this space, in the bottom right corner of your handout, use your compass to draw yourself a circle in that small area. So draw yourself a circle. Once you've drawn your circle, I need you to use that ruler to locate the center of your circle. And you'll need to measure the radius. So locate the center using your ruler, and you need to triangulate the radius. Now the next thing you'll have to do is you need to take your piece of string and you need to cut your piece of string to where it's the length of the radius. So you can just put it on your radius and cut off the extra, or you can measure what was the radius and cut off that amount of your string. If you need a longer piece of string, let me know, I'll get you a longer piece of string. So you're putting your string, one end at the vertex, or the ordinate. The other end, I need to cut off this excess. So cut off the excess. And you'll leave the excess on your desk, that way it fits here to use it. And you'll have to share scissors. Now, we will write down the formal definition of what is a radius, but here's an informal definition. When we use radian measures, it's dealing with the circumference of the circle, and we are measuring the distance around the circle in terms of the radius length. So you now have the radius length in your hand, and I want you to decide how many radii does it take to go from this point to this point. So what you need to do is take your string, let me switch to orange, now let me switch to black. So you're going to start your string right here, and you're going to align your string on the circle. And once you get to the end of the string, you'll just have to mark where does it end, and then you'll have to put your string back on it, mark where it ends, etc. So let me show you what I mean. So whatever your radius length was, you need to start it over here on the right side, align it along the edge of your circle, and measure one radius will not go all the way. So you won't have enough string. So just mark off where one radius ended, and then mark off where the second one would end, and you need to determine how many radii does it take to go halfway around the circle. So you need to start here, and you need to make sure that string makes it all the way to right here, where you're going to end. And that is radian measure. You are measuring the circumference with respect to the radius length. So from that starting point to the ending point, about how many radii does it take to go halfway around the circle? 3? A little more or a little less than 3? A little bit more. So it's about 3, but a little bit extra. What number do you know that's close to 3 with a little bit of extra? Pi. What is pi? 3.14. So the distance from 0 to what we called 180 degrees is actually pi. And that's called pi radians. And it's radians because we are measuring with respect to the radius. So 180 degrees is equal to pi radians. Now we are going to write down the formal definition. So here's the formal definition you need to write down. So the definition for a radius is the ratio of the arc length. And when you're talking about the arc length, you're talking about the part that's being intersected by your angle. So the arc length is just the distance around the circle. So the ratio of the arc length of a certain angle over the radius of the circle, or one radius around the circle. So a radian is measuring with respect to the radius. Okay, the instructions for the next group of circles. It says to label each angle using radian measure and positive rotation. So whenever the instructions say to use radian measure, that's kind of like back in geometry where it said in terms of pi. So all of our answers need to be in terms of pi. And pi is about 3.14 radii around the circle. So in terms of pi. Okay, so problem number 4. On the initial side, we start at 0. It's not 0 degrees anymore, it is now 0 radians. So no degree symbol here, we're in radian mode now. And we just saw that if you go halfway around the circle instead of 180 degrees, it was about 3.14 radii, which is the same as pi. So 180 degrees is now equal to pi. Now up here, this would be half of pi, and the way that we represent that would be pi over 2. So half of pi, we call it pi over 2. Instead of 1/2 times pi, we just sing our notation pi over 2. Now, when it talks about positive rotation, again, we're starting at the positive x-axis, and we're rotating counterclockwise. So here would be 1 pi over 2. Over here, if I keep rotating technically it's 2 pi over 2, but we always leave our answer in simplest form. So that one's 2 pi over 2. If I rotate again, this one would be 3 pi over 2. If I rotate again, this one would be 4 pi over 2, which is equal to 2 pi. So 0 and 2 pi are equivalent. So all of those are in radians. So that's pi over 2 radians, pi radians, 3 pi over 2 radians, 2 pi radians. Next one, number 5. Let me erase this so it doesn't get confused with the answers for number 5. Okay, number 5. Again, we start at 0, and over here is what? In radians, this is pi. And let's figure out what they're counting by. So if I color in that first angle, what fraction of pi does that angle represent? It's 1/4 of pi. So we call this pi over 4. So this circle is counting by pi over 4 radians. So if I keep going in a positive rotation, this one would be 1 pi over 4. This next one technically is 2 pi over 4. And 2 pi over 4 in simplest terms would be what? Pi over 2. So we have 1 pi over 4, 2 pi over 4. What would the next one be? 3 pi over 4. What would the next one be? 4 pi over 4, which is equal to pi. What would the next one be? 5 pi over 4. The next one would be 6 pi over 4. And that simplifies to what? 3 pi over 2. If that was 6 pi over 4, what's the next one? 7 pi over 4. 7 pi over 4. And the next one would be 8 pi over 4, which is equal to 2 pi. And I could keep going. The next one would be 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4. You could keep going. And the next one, number 6. Again, start off by labeling 0 and pi. And let's figure out what are they counting by on this circle. So looking at this first angle, what fraction of pi does that represent? This is 1/6 of pi. So going from 0 to pi, this is 1/6 because I have 6 triangles from 0 to pi. So this would be 1 pi over 6. This one would be 2 pi over 6, which simplifies to pi over 3. The next one would be 3 pi over 6, which simplifies to pi over 2. We have 1 pi over 6, 2 pi over 6, 3 pi over 6. The next one would be what? 4 pi over 6, which is equal to 2 pi over 3. Or the next one would, what would the next one be? 5 pi over 6. And then 6 pi over 6, which is equal to pi. The next one would be 7 pi over 6. The next one would be 8 pi over 6, which is equal to 4 pi over 6. The next one would be 9 pi over 6, which is equal to 3 pi over 2. And the next one would be 10 pi over 6, which is equal to 5 pi over 3. And the next one would be 11 pi over 6. And one more, 12 pi over 6 is equal to 2 pi. So 0 and 2 pi. Did I use any degree symbols there? No. So make sure if you're dealing with radians, you do not use a degree symbol. So no degree symbols with radians. Now, you have a bunch of blank circles. We won't use all of those. I didn't know how many I used. I think we'll probably need about 4 of them. So all the extra ones, it's just extra. I don't know how many I have. Okay, so looking at your first blank circle. Now what I want to do with this circle is to break it up with a special right triangle. We're going to start with a 30, 60, 90 triangle. So I want you to go ahead and mark the center. Now you don't have to get all technical and use the protractor and use the ruler. Just kind of eyeball where the center would be and draw in the initial side. And I want this first one to be a 30-degree angle. So go a third of the way up to 90. So this angle needs to be 30 degrees. Now, in order to do a 30, 60, 90 triangle, I do need to turn that into a right triangle. So I'm just going to drop a vertical here. Drop a vertical. And here is my right triangle. And if the base angle is 30 degrees, that top angle would be 60 degrees. Now, our little diagram we saw a few days ago with the 30, 60, 90 triangles and the 45, 45, 90. The side opposite of the 30-degree angle is X. So that vertical piece is X. Once you know the opposite side of the 30-degree angle, your hypotenuse is double that. So your hypotenuse needs to be 2X. And then the side opposite of that 60-degree angle needs to be X square root of 3. And that's back from the good old geometry days. Now, looking at that special right triangle, we are going to locate some trig values that you need to memorize. So the first one we're going to do is to find the sine of 30 degrees. Now we have to use SOHCAHTOA. So how do you find sine if you have a right triangle? Opposite over hypotenuse. What is the side opposite of the 30-degree angle? X. What is the hypotenuse? 2X. What happens with those X's? They cancel. So what does that equal? 1/2. That's the first thing you need to memorize. The sine of 30 degrees is equal to 1/2. So the sine of 30 degrees equals 1/2. Now the next thing we're going to do is find the cosine of 30 degrees. And using SOHCAHTOA, how do you find cosine? Adjacent over hypotenuse. So what is the adjacent side? X square root of 3. What is the hypotenuse? 2X. What happens with those X's? They cancel. And that gives us square root of 3 over 2. And the last one we'll find for this circle will be the tangent. And using SOHCAHTOA, how do you find tangent? Opposite over adjacent. So the opposite side is X. The adjacent side is X square root of 3. Those X's cancel. So that's just 1 over the square root of 3. Can I leave my answer with a radical in the denominator? No, I have to rationalize that. So make sure you multiply both the numerator and the denominator by the square root of 3. And that would be square root of 3 over 3. Now, when it comes to the unit circle, we often see cosine and sine written as an ordered pair at the edge of the terminal side. So my 30-degree angle is terminated right here at this point. So at the end of the 30-degree angle, we typically see an ordered pair, and those ordered pairs are always in the form cosine, comma, sine. So if I write the cosine sine ordered pair, what do we get for the cosine? Square root of 3 over 2. So in that ordered pair, square root of 3 over 2 would go first. And the sine would go second, and the sine for 30 degrees was 1/2. So if you see a unit circle and it has an ordered pair at the end, that's just giving you the cosine and sine ordered pair. Now, oftentimes students get confused about, well, which one is which? How do you remember? Well, normally ordered pairs are written in what form? X, comma, Y, right? Alphabetic? X comes before Y. Well, C comes before X. So it's still alphabetic. So cosine, sine. So it's still alphabetic. Now, again, make sure you memorize these three. You need to know the sine of 30 degrees is 1/2. The cosine of 30 degrees is square root of 3 over 2. The tangent of 30 degrees is square root of 3 over 3. Now, one other thing I'll point out about the 30 degrees before we move on to the next one is that there's another way you can find tangent. And the other way you can find tangent. So if you are looking for the tangent, we'll talk about this later with our trig identity. Tangent is equal to sine over cosine. And what was the sine of 30 degrees? 1/2. What was the cosine for 30 degrees? Square root of 3 over 2. And what happens with these two? They cancel out. So this is just equal to 1 over square root of 3. Rationalize by multiplying both numerator and denominator by square root of 3. And that gives us square root of 3 over 3, which is the same that we saw on the triangle with opposite over adjacent. So really, all you have to do is know sine and cosine. Because if you know sine and cosine, you can find the tangent by dividing. Okay, next circle. So pick whichever circle you want to do next. So find the next left circle. And just like last time, we're going to just eyeball where it's the center and draw the positive side of the angle, or initial side. And this time, we are going to do a 60-degree angle. So 2/3 of 90. So I want this angle to be a 60-degree angle. And so that we can find the sine, cosine, and tangent, I want you to drop down a vertical line to form our right triangle. And if the base angle is 60 degrees, what's that top angle? 30 degrees. Now this is going to be the same format as the last 30, 60, 90 triangle. The side opposite of 30 is x. The hypotenuse is 2x. And the side opposite of the 60-degree angle is x square root of 3. Now I want you to do these three things. I want you to find the sine of 60 degrees. I want you to find the cosine of 60 degrees. And I want you to find the tangent of 60 degrees. So find those three off of that new triangle. Sine, cosine, and tangent. Using socket toe, how do you find sine? Opposite over hypotenuse. The opposite side is x square root of 3. The hypotenuse is 2x. Those x's cancel. And what is the sine of 60 degrees? Square root of 3 over 2. Cosine of 60 degrees using socket toe is adjacent over hypotenuse. The adjacent side is x. The hypotenuse is 2x. Those x's cancel. And what's the cosine of 60 degrees? 1/2. And for the tangent, using socket toe is opposite over adjacent. So the opposite side is x square root of 3. The adjacent side is x. These x's cancel, and that gives us square root of 3. Or you could have done sine over cosine, and if I make these over one another, sine divided by cosine, what happens with these two? They cancel. So the tangent is square root of 3 over 1. Or opposite over adjacent. Now we'll do 2 more triangles. The next triangle, so find your next empty triangle. The next one is going to be a 45, 45, 90 triangle. So go ahead and mark the center, mark the initial side, and you need to draw a 45-degree angle. And then you need to drop a vertical line to form your right triangle. And if the base angle is 45 degrees, where's that top angle? 45 degrees. And labeling the sides for a 45, 45, 90 triangle, the formula states that the sides opposite of the 45-degree angles are x, and the hypotenuse is x square root of 2. Now I want you to find the sine of 45 degrees, the cosine of 45 degrees, and the tangent for 45 degrees. Okay, for the sine, opposite over hypotenuse. The opposite side is x. The hypotenuse is x square root of 2. What happens with those x's? They cancel. So this is equal to 1 over square root of 2. Now leave a radical in the denominator. No, you need to rationalize that. So multiply both numerator and denominator by the square root of 2. And that simplifies to square root of 2 over 2. Memorize that. The sine of 45 degrees is square root of 2 over 2. Cosine of 45 degrees would be adjacent over hypotenuse. So the adjacent side is x. The hypotenuse is x square root of 2. We just did that, didn't we? So I don't have to redo all of that. What's the answer? Square root of 2 over 2. Then for tangent, that would be opposite over adjacent. So that would be x over x, which is equal to 1. Or if I did sine divided by cosine, what's the square root of 2 over 2 divided by square root of 2 over 2? 1. Now, if I write the cosine sine ordered pair, what would I put for the cosine? Square root of 2 over 2. And what would I put for the sine? Square root of 2 over 2. And I forgot to do that on the last problem, so let me back up. And going back to this one, where the 60 degrees ends, is where I'll put the ordered pair. And what was the cosine? 1/2. And what is the sine? Square root of 3 over 2. Okay, one more triangle. One more triangle. Okay, so after this triangle, we're not using any more of those. So what I want you to do with your last triangle is split it up into quadrants. And right here is the origin, 0, 0. Now, if we're talking about the unit circle, that very first definition for a unit circle, it says that our unit circle has a radius of what? 1. So our unit circle has a radius of 1. So this length is 1, this length is 1, this is 1, this is 1. All of the radii around that unit circle, the radius is 1. Now think about ordered pairs. Think about an x, y coordinate plane. If this is the origin, and I move 1 unit, what would this ordered pair be? The x value is 1, the y value is 0. If I'm at the origin, if I go 1 unit up, what would that point be? 0, 1. If I go back to the origin and move 1 unit to the left, what would that point be? Negative 1, 0. If I go back to the origin and move down 1 unit, what would that ordered pair be? 0, negative 1. Same concept, but now it's on a circle. So if this is 0, 0, what is this point over here? 1, 0. I'm moving out 1 unit because the radius is 1. This point at the top would be 0, 1. This point on the left would be negative 1, 0. And this point at the bottom, let me erase all this. Oh, let me use bigger erase. What would that point at the bottom be? 0, negative 1. Now those ordered pairs are actually the cosine sine ordered pairs. So if I asked you, what is the sine of 90 degrees? What's the sine of 90 degrees? Here's 90 degrees right here. This is cosine, so the sine is 1. What if I asked you for the cosine of 360 degrees? Yeah, here's 360 right here. The cosine would be the first one, which would be 1. What if they asked me for the tangent of 270 degrees? For tangent, I said earlier, tangent is equal to sine over cosine. What's the sine of 270? Negative 1. Cosine of 270 is 0. What's negative 1 divided by 0? Undefined. Oh, you can't divide by 0? No, you can't. What if I ask you for the tangent of 180 degrees? You have to do the same thing. Sine of 180 degrees divided by cosine of 180 degrees. What's the sine of 180? 0. What's the cosine of 180? And 0 divided by negative 1 is 0. So you'll need to know those as well. But if you know where the ordered pairs are, and you know that cosine is the first value and sine is the second value, then you should be able to find those quadrangles pretty easily. Now, as a recap, I'm going to list out what you need to memorize. You need to know that the sine of 30 degrees is equal to what? 1/2. The cosine of 30 degrees is equal to square root of 3 over 2. The tangent of 30 degrees, if you do sine over cosine, would be 1 over square root of 3, which simplifies to square root of 3 over 3. After the 30 degrees, we'll have the 60 degrees, so you need to know the cosine. Following the same pattern, let's do the sine. What's the sine of 60 degrees? Square root of 3 over 2. What is the cosine of 60 degrees? 1/2. And tangent would be sine over cosine, which would be square root of 3 over 2 over 1/2. The 2's would cancel, which would just be square root of 3. And the last special angle is a 45 degrees. And what was the sine of 45 degrees? Square root of 2 over 2. The cosine of 45 degrees was the same. And the tangent of 45 degrees. If you do sine divided by cosine, when you divide these, what do you get? 1. Now make sure you memorize. Go ahead and start memorizing these. You need to know these for Unit 5, 6, 7, 8, and Calculus. So make sure you know these. Now some similarities. Looking at the 30 degrees and 60 degrees, what do you notice that's similar? Yeah, the sine of 30 degrees is equal to what? Cosine of 60 degrees. And what do you notice about the cosine of 30 degrees? It's equal to the sine of 60 degrees. So those are just flipped. So the sine of 30 degrees is equal to the cosine of 60 degrees. And the cosine of 30 degrees is equal to sine of 60 degrees. And then once you know sine and cosine, you can find the tangent by dividing them. And for 45 degrees, these are the same. Make sure you start memorizing those.